All right, this is AP Calculus Lecture 5.10a. You will need to print off the lecture notes that I uploaded to Microsoft Teams for this section. You're going to need to get your inverse trig and hyperbolic formula sheet out, and we'll be working on the back of the sheet today using those. And in the book, open up to page 400 and we'll work off that. So hyperbolic functions, this is just a minor topic for us. We're going to spend 2 lectures on this. Since regular trigonometric functions have a relationship with a circle, the unit circle, hyperbolic functions have a relationship with a hyperbola. And you may have studied hyperbolas in Algebra 2. I don't know, we're going to draw one in this space in a minute. But just reading through the bullets, cables, ropes, chains, electrical wires, when hanging between 2 poles are examples of catenary curves. And these curves are described by the hyperbolic cosine function. So that cosh x, C-O-S-H-X, the way that you say that is hyperbolic cosine of x. The St. Louis Arch is an upside down catenary curve, so that's probably one that all of you have visited, maybe you've been up in. So the hyperbolic functions, there's 6 of those, just like trigonometric functions. Now they're not the same. The reason that they were named this is so that it would make things a little bit easier to memorize, but it's hyperbolic sine, hyperbolic cosine, hyperbolic tangent, hyperbolic cosecant, hyperbolic secant, hyperbolic cotangent. All right, and on those are defined right here where it says the definitions on your sheet. You can see all of the definitions have E involved in them. Okay, so you can look at the graphs of these on page 393. Now we're going to draw this graph. This is a hyperbola, so draw this in your spot on your sheet. And I would be, if we were teaching in person today, I would be interested to see if you guys learned about hyperbolas in Algebra 2. All right, but a hyperbola looks kind of like a parabola, a sideways parabola. Crosses the x-axis at 1 and -1. All right, so that's a hyperbola, and that's what these functions have a relationship with, unlike regular trig functions, which have a relationship with a circle, right? Our unit circle that we've used so much. So the derivative theory, so the next one down, derivative theory of hyperbolic functions. So given that we have the hyperbolic sine of x, we want to know what is f prime of x. Okay, so what we're going to do is look at the definition of hyperbolic sine. We know that hyperbolic sine is e to the x from your sheet minus e to the minus x over 2. All right, that's how that's defined. So we want to take the derivative of that. Okay, so we're going to dx that thing. Well, first of all, let's get that half out front. So bring the 1/2 out front, and then we'll ddx e to the x minus e to the minus x. Okay, well, 1/2 doesn't go away, but the derivative of e to the x is e to the x. And then but that would be minus the derivative of e to the x. The derivative of e to the minus x is e to the minus x times -1, the derivative of the exponent. So that's going to be 1/2 times e to the x plus e to the minus x, because you have a negative times a negative. All right, and we could write that in another way. That could be e to the x plus e to the minus x over 2. Now, if you look at your sheet, you'll see that hyperbolic cosine is that, e to the x plus e to the minus x over 2. Okay, so that's just hyperbolic cosine. So the derivative of hyperbolic sine is hyperbolic cosine. All right, and these functions were defined in that way. They took the derivative of this and they just decided to name this function hyperbolic cosine, so it would be similar to the trig functions that you're used to working with. Now, all of the hyperbolic function derivatives can be found in the same way. We could go through this for all 6 of them. We're not going to. I believe that you probably believe me on this and believe your textbook. So let's work some problems from page 400. All right, the first one, and if you would like to write these notes on the back of the sheet, that's perfectly fine with me. Your choice on that. All right, have this handy. We're going to refer to this. The first one we're going to work is example 2 on page 400. So that says example 2 just wants us to evaluate, so 2a, hyperbolic cosine of 0. So what you do is you just look at the definition on your sheet right here, plug 0 in for x. So that's going to be e to the 0 plus e to the minus 0, and that's just 0, over 2. Well, e to the 0 is 1. E to the minus 0, same as e to the 0, right? That's 1. So that's 2 over 2, which is 1. All right, let's look at 2b. So that's hyperbolic, evaluate hyperbolic secant of 1. Now, if you use your TI-89s and go to the math button, you can probably scroll down and find hyperbolic secant. All right, but we're going to just plug it in to the definition. So hyperbolic secant is 2 over e to the x plus e to the minus x. So we've got 2 over e to the 1, because we're plugging in 1, plus e to the minus 1. Now just put that in your calculator. Take 2, do the 2 divided by, and then left parentheses, e to the 1 plus e to the minus 1. Do something like that, and you should get 0.6, excuse me, let me check my answer, 0.648. So just put that straight in the old calculator. All right, that does it for number 2. The next one we're going to work is number 14. All right, so this is number 14, still on page 400. And number 14 says we're given that hyperbolic tangent is 1/2. And we want to find all of the other hyperbolic trig functions. Well, what we're going to do is we're going to use these identities here, and we're also going to use these definitions. Sine over hyperbolic cosine, 1 over hyperbolic cosine is hyperbolic secant. We're going to use that and then a couple of these identities to get there. Okay, so the first one, you'll see on your identities on your sheet that we have hyperbolic tangent squared plus hyperbolic secant squared is equal to 1. So I can plug 1/2 in for that and square it. So let's, rearranging, we would have hyperbolic secant squared is equal to 1 minus hyperbolic tangent squared. You might remember these similar trigonometric identities from pre-cal. So hyperbolic secant squared is equal to 1 minus, and we know hyperbolic tangent is 1/2. So 1 minus 1/2, we've got to square that. That's going to be 1 minus 1/4, which is 3/4. So that's hyperbolic secant squared. To get hyperbolic secant, we would just take the square root of 3/4, which is going to be the square root of 3 over 2. Now hyperbolic cosine, so that's our first one, and we'll circle that. The rest of them are going to come pretty quick. hyperbolic cosine is 1 over hyperbolic secant. All right, that's from your sheet. So just flip hyperbolic secant. We've got that one. We also know that hyperbolic tangent is hyperbolic sine over hyperbolic cosine. So to get hyperbolic sine, we don't have that one yet. We can rearrange that equation. It's hyperbolic tangent times hyperbolic cosine. So hyperbolic sine would be 1/2, because we know hyperbolic tangent's 1/2. It's where we started. Hyperbolic cosine, we just figured out. That's 2 over the square root of 3. The 2's cancel out, and you would have 1 over the square root of 3. So now we've got 3 of the 5 that we need. Hyperbolic cosecant is really easy because we're just going to flip hyperbolic sine. So that's going to be square root of 3 over 1, which most people would call the square root of 3. Now we got 4 out of the 5. The only other one we need is hyperbolic cotangent. Well, as luck would have it, hyperbolic cotangent is the reciprocal of tangent. So we're just going to flip tangent. So 2 over 1. So that's 2. So very similar to what you did in pre-calculus with the trigonometric identities. Some of them are slightly different than the trigonometric. Just make sure you follow the sheet. All right, it's not hyperbolic sine squared plus hyperbolic cosine squared is equal to 1 like it was with trig. Follow this. They're a little bit different, some of them, so be careful. The tangent one is the same, but the others are a little different, so be careful and don't use the regular trigonometric identities. All right, so pause if you need to. And just one little note here before I work a couple more problems. In differentiating hyperbolic functions, we use the same techniques as other functions. So you're not having to reinvent the wheel here. You're going to use the same techniques like the product rule, like the quotient rule, the chain rule. Doesn't go away. Okay, so that makes things pretty good for us. So I'm going to work 3 examples from the book, and that should be enough for you to be able to do the homework. So example 16, we're still on page 400. All right, we want to know the derivative of hyperbolic cotangent of 3x. Well, you're going to use your sheet. You do not have to memorize these. They're pretty similar. Sometimes they're a little bit different. Let's find hyperbolic cotangent. And we see the derivative is minus hyperbolic cosecant squared. So it's going to be minus hyperbolic cosecant squared of the blop, 3x, times the derivative of the blops, not the blops. Haven't done one of these videos in a while, so a little rusty. So times 3. So that's going to be minus 3 hyperbolic cosecant squared 3x. These are a mouthful to say. It'll be interesting when we get back to class to hear you guys pronounce all this stuff. Right. My guess is that you won't. That you'll make me do all the talking. All right, example 18. We have g of x is equal to the natural log of hyperbolic cosine of x. So g prime of x is equal to, okay, how do you take the derivative of a natural log? 1 over the blob. 1 over hyperbolic cosine of x times the derivative of the block. Well, what's the derivative of hyperbolic cosine? You don't have to memorize it. Just find it on the sheet. It's hyperbolic sine. Not minus hyperbolic sine, by the way. So be careful. Use your sheet. So that's going to be hyperbolic sine x over hyperbolic cosine x. And that happens to simplify down to hyperbolic tangent of x. So I do expect you to do a little bit of simplification. Not what the back of the book will do. They go kind of crazy on that. And one more example. All right, so not too long a video today. We have h of t is equal to t minus hyperbolic cotangent of t. So coth t. All right, h prime of t. Well, the derivative of t is no different than what it was before. It's 1. The derivative of hyperbolic cotangent, we actually did this just a minute ago, is minus hyperbolic cosecant. So minus minus would make a plus hyperbolic cosecant. Don't forget the h. I'll have to count off on your test. Get that h in there. Squared of t. Now, if you look at your identities, 1 plus hyperbolic cosecant squared, if we move this to the other side, is hyperbolic cotangent squared. So I'd be really proud if you remembered to look at your identities and simplify. But if you stopped right here, I would not count off. But you want to make the teacher proud, right? Okay, pause if you need to, and then I'll write down the homework. You already have it on your schedule. All right, the homework is page 400. You got to do 1, 13, 15, 17, 19, 20, 21, 23, 24, 26, and 28. Now, on some of these, the answer in the back of the book is fine. Some of them, they simplify more than I will require. So don't worry about simplifying too much. They'll use the identities to go crazy on the simplification. I would like you to, let's see, identities. I would like you to, you know, sine over cosine is tangent, that kind of thing. Let me go ahead and write down the answers that I would accept on a few of these. So starting 1, 13, 15, 17, 19, I don't think you'll have any trouble with at all from the back of the book. Number 20, the answer is x, hyperbolic cosine x. All right, 21, 1/2 hyperbolic cosine 2x minus 1/2. I think they go further than that in the back of the book. Same for 23. I would be happy if you will get to hyperbolic cosine of t, cosh t, over 1 plus hyperbolic sine squared of t. You could simplify that down more, but that's fine with me. 24, we got hyperbolic cosine x times e to the hyperbolic sine x. 26 minus 6 hyperbolic secant squared 3x times hyperbolic tangent 3x. That's probably the same as the, well, no, 26 wouldn't be in the back of the book, would it? And then 28 minus hyperbolic secant minus hyperbolic secant is the way you say that, x plus 1 times the hyperbolic tangent x plus 1. All right, so go ahead and try this homework. I will put an assignment on Microsoft Teams, and you'll see that it would be due on Thursday. And I will talk to you next video.